Hello guys. So welcome back once again in our channel. Today in this video we are going to learn about capacitors and diode. I hope you have watched my last video. So in the last video we all have learned about the switches as well as we have learned about the potentiometer. And if you see the first video, in the first video we have explained we have learned about the voltage, current and resistance, and also we have learned about the series and parallel connection of the LEDs. In this video we are going to learn about the capacitor and the diodes, which are very important component in the electronics. So before I start the video, if you are watching this video the first time, then please like and subscribe to our channel. So let's start. First, I think you all have seen the capacitors in the real life scenario, and I hope you have heard this name also. So basically capacitor we all have seen in the fan, but in the fan we used to call with a different name, which is called condenser. So do you know what is the use of condenser in the fan? Or if you see any development board, you can see there are many numbers of condenser or capacitor is present on the board. So what is the use of those capacitors? What is the use of those condenser? Today in this video, all your doubt is going to be clear, because I'm going to explain about the capacitor in a much better way so that you can understand, and also I'll be covering with the analogy so that you can understand in a better way. So here you can see the definition. A capacitor is a passive component that has the ability to store the energy in the form of potential difference between its plates. So basically a capacitor is a kind of a battery which stores the electrical energy inside it. So we can say it's a kind of battery which charge and discharge very fast. So depending on the value of the capacitor, its discharge time and charging time will be vary. So here you can see it resists a sudden change in voltage. The charge is stored in the form of potential difference between two plates. So basically a capacitor is made up of two plates. It's a kind of sandwich between two plates, between two metal plates. There will be a dielectric material which is an insulator. So it is made up of two plates, which is the metal, mostly it will be aluminum, and the middle layer will be dielectric, which is a kind of insulated material. So as I have told you, capacitor is a passive component. So far I have not explained in my last video also what is passive component, what is active component. So I will explain what is the active component, what is the passive component in this video. So here you can see what are the active components. The active component doesn't need any external power supply. So here you can see these components are part of a circuit that rely on an external power source. Sorry, I told wrong. These components are parts of a circuit that rely on external power source to control or modify electrical signals. Active components such as transistor and silicon controlled rectifier, these all are active components. And whatever components we are using today, capacitors and diode, which we are going to cover in this video, those are actually passive components like resistor, transformers and diodes. And capacitor also, it's a passive component. So today in this video we are going to learn about the capacitors and diode. So both are passive components because they don't need any external power source to operate. So I hope you these active and passive things will be clear to you. What is the active components? Active component needs external power source to control or modify electrical signals, but passive components does not rely on the external power source. As in the last video we have used a resistor to limit the current. So a resistor was not rely on the external power source, so that is also a passive component. So let's move on to the next slide. Here you can see we have seen these kind of capacitors on the development boards, on the microcontroller boards. The standard unit for capacitor is farads, and in the last video we have learned about the resistors also. So resistors is measured in ohms, but capacitor unit is farads. So the capacitance, the property of the capacitor is called capacitance. Generally, the value of capacitor available will be in the order of microfarads, picofarad, and nanofarad. So we have seen this is the blue one is the actually electrolytic capacitors. So here you can see the value of electrolytic is written in microfarad. So this capacitor is the bigger one, blue in color. The value is 4700 microfarad, and as well as the rating, voltage rating is very important. You cannot give voltage more than the rated voltage. So the voltage rating is 35 volt. So this is the breakdown voltage of the capacitor. If you give more than this voltage, it can be dangerous and all your components can be damaged. So these things we have to keep in mind. Always we have to keep in mind, you never give the voltage above the rated voltage. So this capacitor value is, capacitance is 4700 microfarad and the rated voltage is 35 volt, which is also known as breakdown voltage of a capacitor. Here is the symbol of a capacitor is given. So you can see this is the symbol of capacitor. So there are two symbols. The left one, if you see, this has a polarity. So electrolytic capacitor have a polarity. This blue in color, this one and this one and this one, this one. These all things are actually electrolytic, but this orange in color as well as this green one and this blue one, sky blue color, these all are ceramic capacitors. So ceramic capacitors doesn't have any polarity. That's why you can see both the plates are on same size. But if you see this one, the upper one is actually positive and the down one is negative. Yeah. So till here, if you have any doubt, please put your comment. Okay, moving on. Now we are going to learn about capacitors in series. If we connect the capacitors in series, what will be the effect in a circuit? And if we connect the capacitor in parallel, what will happen? So here you can see when capacitors are connected in series, the total capacitance is less than any one of the series capacitors, individual capacitance. If two or more capacitors are connected in series, the overall effect is that of a single capacitor having the sum total of the plate spacing of the individual capacitor. This is the formula basically. C total means capacitance total equal to C1 by into C2 upon C1 plus C2. So here in this image you can see two capacitors are actually connected in a series and the total capacitance will be this formula, C1 into C2 upon C1 plus C2. Okay, moving on. So now we'll do one thing, we'll make a circuit and we will learn about the series capacitance. So let me open Tinkercad. In the last two videos also I have used Tinkercad to explain the circuits. So let's use and let's connect two capacitors in series and let's see the variation. And also we will be comparing today in what condition we should use the capacitors. Should we use the parallel combination or should we use series combination? So let me take circuit. Okay. So here it is open. So I will just write here capacitor. Capacitor is here. I will take 3 capacitor. Yes. And then I will take a power supply bench. So here we have a power supply. So the series connection will be like this. Plus of the first capacitor we have to connect to the minus of the first one, minus of the second one, and then second positive we have to connect to the third negative. Again we have two terminals left, the first negative leg and the third one positive leg. So I will connect negative to the negative of the power supply, and then I will connect positive to the positive of the power supply. Yes, so we have made a series connection using three capacitors. So let me take a multimeter to measure the voltage, and also we will observe, as I told, capacitor is used to store electrical energy. So let me connect the multimeter. So I will connect negative of the probe to this capacitor, first one, and then positive probe I will just connect to the third capacitor, positive. And let me start the simulation. Before starting, let me change the value of the capacitor. So this is rated 1 microfarad. Let me make 100 microfarad, and then this one also 100 microfarad, and this one also 100 microfarad. Now let's start the simulation and let's observe the circuit. So here we are applying 5 volt. Let me increase the voltage because the maximum volt we can provide 16 volt. Here you can see the voltage rating is 16 volt of this capacitors. So let me give 12 volt. I will just do here 12. Okay, so we are providing 12 volt, and here multimeter is also showing 12 volt. Let me turn off the bench, power supply bench, and just keep an eye on multimeter, because now when I turn off the power supply, this voltage is going to reduce at drastically speed. So let's see. Here I am going to turn off this power supply, and just keep an eye on the multimeter. It will start discharging because the value is very high, so it will discharge very slow. You can see started discharging 11.9. So it is taking time because the value of the capacitor is 100 microfarad. If we reduce the value, it will discharge very fast. Let me show you. Here it is discharging very slow, 11.9. Let's wait. Yeah, you can see 11.8. But let me change the value because the value is high. So let me give 10 microfarad only, and let's see. 10 microfarad, and this one also 10 microfarad. Now let's observe again. So it's on. Let me turn off. 11.9, 8. So you can see the discharging time is increased. Now you can see it is discharging faster than the previous one. But if the value will be 1 microfarad, it will discharge very fast. So totally it is dependent on the capacitance. So this time I am using 1 microfarad. Okay, now let's see again. So power supply is on. Here also we are getting 12 volt. Let me turn off this, and you can see it is discharging at a very fast rate. So hence it is proof. Capacitor is a charging storage device. It is storing electrical charges. Whenever we are providing the power supply, whenever we are giving the supply to capacitors, it will do charge first, but there is a limit. It cannot store more than that charge. So every capacitor have a capacity. It cannot, if it reaches to that capacity, if it reaches to that threshold, then it will automatically stop charging, and once you remove the power supply, it will start producing the supply to the circuits. And in every electrical appliances there is a capacitor. Now I'll explain what is the use of capacitor in electrical appliances. Like Earlier I told in the fan, if you see there is a capacitor white in color, that is also known as condenser. So in our home, alternating current comes, right? But if you see the graph of alternating current, it's a sinusoidal wave, right? It's a sine wave. But what happens? Sine wave can be high and low at a very fast. 15 hertz is the frequency which comes in our home, right? So sine wave changes at a very fast rate. So sometimes voltage can be high, sometimes voltage can be low. So that will give a bad impact on electrical appliances. What capacitor does there, whenever the voltage will get high, that will this capacitor will bear that load, and whenever this voltage will become low, then capacitor will provide the proper voltage to the device so that it cannot be damaged. That's why in every electrical and as well as in electronics also, capacitor is being used in a majority. Okay. So here you can see it is decreasing. Now it came in a millivolt. So I hope you have understand what is the use of capacitor in electrical appliances, and in electronic applications it is used to reduce the noise, to filter the circuits. I will explain about that also. So in an electrical appliances, capacitor is used to bear the voltage fluctuation, because alternating current is a sine wave. Every time it will like become high and low continuously. So in order to in order to maintain the range of the voltage which is required by the appliances, capacitor is being used mostly. Now moving on. Okay, so we have learned about the series connection of the capacitors. Next is capacitors in parallel. So when capacitors are connected in parallel, the total capacitance is the sum of the individual capacitor capacitance. So this is very simple. Here you can see, let's say here you have connected two capacitors. The sum of total capacitance will be C1 plus C2. So here what we have to do, let me show you again the parallel one. I will just do stop simulation and I will connect these capacitors in parallel this time, and I will keep the same value 1 microfarad, so that comparison will be more easy. We have seen what happens in the series connection. In the series connection also it is stored the energy, but the discharging speed was very fast. This time I am going to connect in parallel. So parallel connection, in parallel connection what happens, positive of the first one has to be connected with positive of the second one, and the positive of third one also we have to connect. So basically all positive leg we have to connect to each other, all negative leg of the capacitor we have to connect to each other, and this way we will be able to make parallel connection of the capacitors. That's it. Here I have negative leg of the capacitors, I will directly connect to negative, and this positive leg I will connect to positive of power supply. Again let's connect the multimeter. So this is positive, I will connect to positive, this negative I will connect to negative. Okay, so we have done the parallel connection. This time also every capacitor have a value of 1 microfarad. Same value we have seen in the series connection also. So comparison will be quite easy, because we have seen in the series connection the capacitance will be divided, but here the capacitance will be added. Let's see that. Okay, so here we are providing 12 volt. In the multimeter also it is showing 12 volt. Let me turn off the power supply, and you can see It is discharging, but this time it is slower than the previous one. This time it is slower than the previous one if you observe the multimeter. Or I'll do one thing, I will make one more combination and parallelly we can compare both series as well as parallel. So let me do the connection again, so that comparison will be quite easy. Here I am just going to show what happens in the series connection of the capacitors and what happens in the parallel connection of the capacitors. So let me take capacitor again, we need 3. I will keep both here, series and parallel, so that we can compare both at a time. Multimeter, okay, I have a multimeter also. Let me connect all positive to not to each other. Here series connection I am going to do. Positive of the first one we have to connect to the negative of the second one. Then second positive, third negative. And then negative we have to connect to negative. Let me take another power supply bench for this circuit. Okay. So I will just write power supply. Here we have another power supply bench. Okay, negative, let me connect to negative, and then positive, let me connect to positive. Simple. Okay, so here positive I will connect to positive, and this negative probe I will just connect to negative of this one. Okay, so we have both things. Let me choose the value 1 microfarad, 1 microfarad, 1 microfarad. We have to keep everything same in series and in parallel. So both is same. Here also I have put it 12 volt. In this power supply also I am providing 12 volt. Let me turn on this again. Okay. In both circuit you can see we are providing 12 volt and on the multimeter it is showing 12 volt. But the top one is parallel combination and the down one is series combination of the capacitors. So let me turn off the power supply bench and let's observe the circuit. So you can see the difference clearly here. What is happening in series connection, the capacitors are discharging at a very fast rate, but if you see the top one, which is parallel connection of the capacitors, it is discharging very slow. So that's what happens in capacitors. In parallel connection, all the capacitance of the capacitor will be add-on, but in series connection it will not like that, because the formula is C total equal to C1 into C2 upon C1 plus C2. So here you can see the parallel one is still 10 volt and this one is 2 volt, almost 2 volt. Okay, I hope you guys have understood. If you have any doubt, please put your comments. And guys, if you are new on this channel, please like and subscribe to Rohopner channel, because in the future videos we are going to learn a lot of things in robotics, and we are going to build a very good robots, and we will be building many autonomous robots also. So moving on, let me open the slides. Yes. So now we have learned about the parallel connection also. Now in the power supply boards we have seen many numbers of capacitor, like this is the power supply. So here you can see all AC DC converters, whether they are linear supplies or have some kind of switching elements to them, require a mechanism to take the varying power on the AC side and produce a constant power on the DC side. Typically a large filter capacitor is used to absorb and store energy when the AC power is higher than that than what is needed by the DC load, and to supply energy to the load when the AC power is lower than what is needed. That's what I have explained in the fan. I took the example of the fan and I explained you, like whenever AC is fluctuated at very fast rate, the frequency of AC in our home is 50 hertz. So what happens, whenever the voltage will become high, the capacitor will bear the load, and whenever the voltage will become low, the capacitor will provide the appropriate voltage whatever is required by the appliances, so that it will not be damaged and the life span of your device will be longer. Moving on. Okay, so capacitor in a circuit, let me show you one more circuit of the capacitor where I will use LED, and we will see the LED connection, and with that connection again we will understand the parallel combination. So this time I am going to connect the capacitor in parallel, because we have seen if you connect the capacitor in parallel, the capacitance will be more. See, here I am going to take LED, and I will take a resistor also. Okay, so I have taken LED and resistor. Let me connect 1 kilo ohm resistor to power supply bench, and this minus I will connect to the minus. Okay, and now I'm going to turn on the simulation and just see what happens. So the LED is on, we are providing 12 volt, and now I'm going to turn off this power supply. You can see it is discharging now, this time very fast, because we have connected two things. The capacitance is actually coming to the LED, and the capacitor is giving power to the LED. And because the capacitance value is 1 microfarad, that's why the LED turned off quickly. But if I increase the capacitance of each LED, this time it is 1 microfarad. Let me give 10 or 100. Let's see with 100 what happens. I will just do 100. Yes, 100 microfarad. So I have changed all of the capacitance. 100. Let me do start simulation. And 12 volt we are giving. Now I'm going to turn off power supply, and see it is actually turning off very slow. LED needs 2.5 volt to glow at max brightness. If the voltage will go below that, it won't glow. So still it is glowing, but it's very dim, even you cannot see properly. This resistance value is 1 kilo ohm. Let me do 470 ohm. Okay, now let's do start simulation again. Now let me turn off power supply. You can see it is discharging. What happens whenever at the beginning I gave the supply, that time capacitor was charging. When I turned off the supply, it started discharging, and the discharging and charging we can clearly see in the multimeter. Here the value is 100. Let me show with 1000 what happens. 1000 microfarad, the voltage rating is 16 volt. Again, let me turn off this. This time you can see. Same thing happens in an electric circuit. First capacitor charges, then once the supply went off, then it will start discharging. Okay, now moving on the slides. So we have learned about the capacitor, series connection of that, and parallel connection of that. Now we are going to learn diode, which is again a very important component. We have seen a diode in all the boards actually, all the microcontroller boards, all the development boards, all the power supply pins, as well as diodes are actually used in the rectifier circuit also to convert alternating current to direct current. So here you can see the definition. A diode is a semiconductor device that essentially acts as a one-way switch for current. It allows the current to flow in one direction only. In the reverse direction, it opposes the current. Diodes are used as a rectifier in a circuit. It converts AC into DC, as well as diode can be used as a switch also. Most of the time we have seen diode as a switch, but for the conversion, this is also another application of diode. Diodes have polarity anode and cathode. Here this is the symbol of diode. Left side is anode, and if you see visibly, the black color is anode and the gray color is cathode, which is negative. And LED is a kind of diode, which is light emitting diode. LED is also diode. There are different type of diode. Depending on the application, you can choose the appropriate one. Here this red one is Zener diode, this is generic diode, and this is light emitting diode. Moving on, types of material. So we all know there are three types of material: conductor, insulator, and semiconductor. So we are going to learn about semiconductor, but also I will discuss with you about conductor and insulator. So we all know what is a conductor. Conductor is a material through which electricity can easily flow through it, right? What is an insulator? Insulator is a kind of material through which electricity cannot flow. But what is a semiconductor? Because we have seen diode is a semiconductor device which makes the current flow in only one direction. So today the topic is semiconductor, so we will be focusing on this. Semiconductor can behave as a conductor or as an insulator on also depending on the direction of the electricity flowing through them. So semiconductor material is like silicon, germanium, those are semiconductor material. So here you can see the energy gap comparison. So why in insulator current cannot flow through it? Because the gap between conduction band and the valence band is more. So here you can see the energy gap between conduction band and the valence band is very big. That's why electricity cannot flow through it. And in the semiconductor you can see the difference between conduction band and valence band is middle of both of them. Here you can see in the conductor what happens, conduction band and valence band are overlapped to each other. That's why free electrons can jump from this, and whenever you give the supply, electricity can easily flow through the conductors. But if you give power to the semiconductor, because conduction band and valence band is actually differentiate with the energy gap, so if you take a pure semiconductor material, it will not conduct, like electricity will not conduct in a pure semiconductor material. So in order to conduct electricity in semiconductor, we used to mix another elements. So pure semiconductor material is called intrinsic semiconductor. If we mix some other element, so there will be two type of element we can mix in semiconductor. Either it will be tetravalent elements or it will be pentavalent element. So if we mix some element to semiconductor, it is called extrinsic semiconductor material. So if we mix tetravalent elements like boron, in boron there are the atomic number is 5. So what happens if you mix the 5 number with the silicon? In the silicon the atomic number is 14 and the outermost cell will be 4 electrons. So here you can see if you mix the tetravalent, all the electrons will share the spaces, but one hole will be left out, and this is called positive. This is positive charge basically, because electrons are negatively charged, so we will consider hole as a positive charge element. So here in p-type, one hole will be left out. So in p-type semiconductor material, uh, one hole is left out. That's why p-type semiconductor material is also called positively charged material. And in n-type semiconductor, what happens? Here there are 5 electrons, so one electrons will not able to make a group, so it will be free electrons. So extra electrons will be there. That's why n-type semiconductor material is also called majority carriers of electron. And in p-type, the majority carriers will be whole. Okay, so now we will discuss about p-n junction diode. So if we take the p-type material and n-type material, and if we combine both together, p-n junction will form. In this situation, what happens? From the n-side region, electrons will start diffusing towards the p side, towards the this depletion region. So what happens? If electrons moves towards the junction, the negatively charged carriers will found a boundary, and after this there will be no movement of electrons. Due to that, one barrier will form, which is also called depletion region. So if you don't give any power supply, this diode will not work because a barrier is formed here. Now I am going to explain how we can use diode. So there are two ways. Either diode will work in a forward bias or it will work in a reverse bias. In the reverse bias, diode will work as an open switch. In a forward bias, diode will work as a closed switch. Here you can see how we can make forward bias and reverse bias of a diode. So let us understand that. In P region, the majority carriers will be holes. In N region, the majority carriers will be electrons. Here you can see minus are actually electrons and this white circle are holes. So if you connect positive to P side and negative to N side, here you have seen positive we have connected to the battery of positive, and then negative we have connected to the negative end of the battery. This is called forward bias, and in this situation current flows. And just next to that, left side you can see positive we have connected to negative, and negative, which means n-type material we have connected to positive. This condition is called reverse bias, and in this situation current doesn't flow, and the device, the state will be open switch, and in forward condition the state will be closed switch and current will flow in one direction only. So here left side I will just explain. So here you can see, because these are holes are positively charged, so if you connect the battery P type to negative, then all holes are actually attracted towards the negative of the battery, and this side also all electrons will pull to the positive of the battery, and the depletion layer will be expanded, and the diode will go in the reverse bias. But in the forward bias, what happens? If you connect positive and negative, like P type, if you connect to positive of the battery, and if you connect negative of the battery to N type material, all the electrons will start moving towards the whole side, P type side, and again from this side also, from the negative side, again electrons will start moving towards the junction, and there will be potential difference. If you provide 0.7 volt in the case of silicon, if you provide more than that, then current will start flowing through the diode. Now let us understand this scenario in Tinkercad. Let me take a diode, then I'll show you. So LED is also a diode. let me show you with the LED. So we have seen, in order to glow an LED, we have to always give positive to positive and negative to negative. If you do reverse, LED will not glow. Same thing, if you give reverse, LED will go in reverse bias and it will not glow. So let's see. So this is positive, I will connect to positive. This is negative, I will just connect to negative. And you can see LED is glowing. But if I do reverse of it, it will not glow. If I connect negative to positive and if I connect positive to negative, the LED will not glow. This time it becomes reverse bias and it is acting as an open switch. Let me take generic diode here. Now I will show with this diode. Okay. So I will just connect to this and then this one. First we have to connect this to positive. Positive, yes, I have connected to positive. Then this I will connect to negative. And here you can see LED is glowing. But if I change the direction of this diode, now this time I will connect negative here and then this positive I will connect to negative. And now you can see it is glowing, but let me do the reverse. Positive I will just connect to this and then negative. This time negative, yes, and then this is actually going to positive. There is some problem. This zener voltage, let's do 0 volt. Due to the zener voltage, it was glowing in the reverse bias also, but now this time I have reduced the zener voltage. That's why you can see LED is not glowing. Let me do this voltage 2.5 volt. You can see LED is not glowing. If I increase the voltage also, at 4.5 volt also it's not glowing, but if I increase more than that, it will go in the reverse bias and it will glow. Let me show you this things with a motor. Because I have taken the zener diode, so zener diode works in the reverse bias. So I should take this one. Instead of that, I took the zener diode. So zener diode works in reverse bias also. Now I show with this diode. So depending on the application, we should choose the appropriate one. Here I showed you zener diode works in reverse bias. Negative, I will just connect to negative, and this positive, I will connect to positive. And let me turn on this. And what you can see here, LED is not glowing. But here, if I reverse this thing, let me show you this connection. Let me delete this. I will just rotate this diode and let's see what happens. Let me delete this. I will rotate this diode. And this time LED should not glow. But this time also it is glowing because there is some problem again. Diode. Oh, again it is zero. This one plus minus, and let me show this is okay. Yes, it's not glowing. And in the previous time we have seen it is glowing. So here you can see it is not glowing, but if I remove, if I rotate it, it will glow. So it is proof diode can make the current flow in only one direction. It will block the current in reverse direction. Here you can see it will glow this time. Yes. So we have seen how does a diode work as a switch, and we have also learned it flows the current in only one direction, but we have seen with the Zener diode it works in the reverse bias. Here in this generic diode, which is IN4007, in this diode, because this is generic, in reverse bias it will not work. But with Zener diode is actually made up to work in reverse bias situation. So here you can see Zener voltage is 5.10. If I connect this diode instead of this, in this situation also, it will glow. Let me change this thing. Let me rotate it and let me delete this wire. I will connect this again. Okay. Now here with the normal diode it is not glowing, but if I connect in same manner, if I connect Zener diode, the LED will glow, because Zener diode can work in reverse bias also, in reverse condition also. So here it is a reverse condition and you can see the LED is on. So there are different kinds of diodes. Depending on the application, we can select the appropriate one. Again, moving on the slides. The diode has a PN junction. In a diode, P region has lightly doped holes. So, and as the majority carriers in P-type material, holes are the majority carrier. In N-type materials, electrons are the majority carriers. And diode can also be used to convert AC into DC, which is called rectification. So diode can be used as a rectifier also. So that's all in this video. If you have any doubt, please put your comments. And in the next video we are going to learn another interesting topics, and again in the next video we'll be doing very interesting circuits. So I hope you enjoyed this video, and I hope you have learned a lot of things about the capacitors and diodes. So please don't forget to like and subscribe to our channel. We'll catch up in the next video. Thank you.